All right, good morning, everybody. Happy Pi Day. Happy almost Friday, which means almost spring break. This lecture is going to look a little different. Last few weeks, we've been talking about soil stress and all the fun stuff that required math and really the theory behind geotechnical engineering. In this lecture, we're going to be covering something a little bit more practical. So I'm going to be reviewing some online site investigation tools that are commonly used in geotechnical subsurface or site characterization reports. So if you rewind back a few lectures, or sorry, a few months ago when we were talking about roles of the geotechnical engineer, they're usually the first ones in at the project site, and they need to not only define the subsurface conditions, but also the general site conditions. So what was there in the past? What was the site used for? What could there be potential construction issues or potential design issues? So usually you need to cover all your bases, and luckily there's a lot of tools out there, mainly maps and data sources that are available for us to use and to really get an understanding of what the site was used for in the past. So I'm going to review four different types of techniques, or so four different tools. And it's important for you to at least understand where these tools are and how to use these tools, but it's also going to be important uh, because you're going to need to actually practice using these tools for your last lab report. So at the end of this lecture, I'll go over that final lab, and I'll post that a little bit earlier too, so you can get a head start working on that. And essentially what you're going to be doing is producing a site investigation report for me for any project site, any location in Florida that you care about. All right, so let's get started. Big picture again, the geotechnical engineer's job is to produce these consulting reports. So they're going to be looking at what's there at the project site, what's been analyzed, what has it been used before, and then what's recommended. So I've harped on this so many more times, but the key thing with geotech is that each site is different. So there's the subsurface investigation side of things where we're talking about the drilling plan, where you would actually look at perform our standard penetration tests and cone penetration tests, determine the soil strength, and as well as lab testing. But also what we're going to be producing too is just a general engineering report or site characterization report. And so with those site investigation tools, geotechnical engineers will always utilize four or most of these references here. So I'll post also some example reports, some real world geotech reports that you'll see these things actually utilize, and I'll show some slides here throughout as well. But the four site investigation tools will be USGS, the United States Geological Survey, topographic map. And so if you're unfamiliar with topographic maps, I'll review what those are here in a little bit. Another really valuable tool is actually out of the University of Florida. Their library, digital archives library, were able to access the historical aerials. So way back, all the way in 1940s, for agricultural use, we have like essentially spy planes taking pictures of what the Earth looks like before satellites, before we had like Google Earth and everything. So we can use those to our advantage to see what the site was like before it's been developed, or way back in the 40s before we actually had proper documentation of everything. Another really valuable application is the Florida Department of Transportation public boring application. So this is a new endeavor. It's actually really, really, really convenient. And if you work in the geotech space, you will definitely utilize this. Essentially what DOT was saying was like, or what their idea behind this is that, well, hey, like all of these taxpayer funded projects where the taxpayers are funding for these or paying for these new roads and new bridges and everything. So the taxpayer should have access to the data associated with that as well. So this is a really nice GIS platform where anyone can log on to it and see a map of Florida and see all these little dots where standard penetration tests and where cone penetration tests have been performed. And if you click on that little dot, then you can download the report that's actually associated with that. So you can then get a sense of nearby site subsurface conditions, even before you go and drill at your own project site. And then the last one that I want to share is this soil web survey. And this is one of those kind of not really meant for engineers, but we still use it as engineers' tools. This was made by the United States Department of Agriculture, so USDA. And there's some limitations with that, but it still gives us a good understanding of the spatial distribution of soil at the surface. So at least gives us can help us identify any construction issues or site access issues. So let's first talk about topographic maps. So topographic maps, those show the anticipated or generalized contours of the ground surface elevation. But so they will tell us the anticipated landscape in terms of hills, valleys, riverbeds, all that fun stuff. So it's all based off of digital elevation mapping or survey mapping, depending on the year that you actually collect these from. And these will help us greatly when it comes to anticipated drainage of our site, the fill requirements. So if you have a bunch of valleys and low areas or high areas and you're building a super large flat warehouse, then you can get an estimate of the type of soil fill that would be there, as well as pre-existing structures. And the benefit actually is we have topographic maps dating all the way back to 1950. In some areas, these larger topographic maps, you can get them back to 1914. And with these large historic topographic maps, you can sometimes identify things that the historical aerials won't pick up on. Like for an example, like an old sewage disposal site, and I'll show an example of this actually in Jacksonville here, or old strip mines, like old mining or old quarries that now might have been filled in the 90s or the 80s. We can actually get an understanding of what that site was used for before documented history, I guess. So the link is here below, and I'll show these examples at the end of the lecture here, and I'll also include these links. But if we click on this link, then we're able to access a GIS map of all the world actually, or sorry, all of the United States. And then we can actually choose a point of interest where we want to view these topographic maps. Now, there's two types or two categories of topographic maps that you'll see. One is going to be called 7.5 minute topograph, and the other one will be 100K topograph. Now, ask a surveyor what those mean, or it has something to do with like the arc of the size of the map, like in terms of like the arc or the surface area of the earth that it covers. But what you need to know is that the 7.5 minute is going to be this higher resolution, smaller scale. So if that is typically what is used for site projects, because we want to be able to view it in terms of like a project site, a lot, not necessarily a whole city. So the 7.5 minute, that is going to be used for your site investigations, where your 100K is a larger scale. So this would be more so for your whole city or whole region scales. So for example, like the most recent ones, they look really pretty, and I'll show you a zoomable one here. It looks, this is a 7.5 minute one for the Arlington area. What you'll see too is there's these maps that are based off of certain plats or certain regions, and you can't really pick and choose. You can't we have this map, and you can't the only way to actually like zoom in is to zoom in on this map. They don't make anything smaller than this. But what you can see is typically for geotechnical reports is you would zoom in on a certain area of interest. And the map on the right there, that's from 2021. And so we can actually crop this and compare it to some of the pre-developed sites. So the 1950s one here. So this specific area is, I'll show that in the example here later on for the historic aerials, but this is actually the South Side Expressway with 295 over by the Regency Mall. And you can actually see here in 1950, this area, this is Atlantic Boulevard going here. So this little line there, that's the same line here. So this is before they built the Arlington Expressway. You can see Strawberry Creek is shown right here, and now it's all developed with the neighborhood, the Southern Arlington area. But actually this whole thing right here, you can see if you zoom in, I don't know if it'll let me. Yeah, okay. So this is actually a strip mine, and that's where they ended up putting the entire, right, that's where they ended up putting the Arlington Expressway. the Southside Expressway interchange, and then also the Regency Square Mall. So we can see not only the changes of the ground surface, but as well as the changes of maps, the changes of the topography, changes of landscape over time as well. So we'll go over this one in a little bit more detail. The topographic map is usually the first thing that we look at, and then to get a more accurate representation, or to get another like little magnifying glass here in what we're studying, we can also look at the historic aerials. So the historic aerials are just that. We don't have actually any real data, and most of them are, or some of these are going to be grainy depending on the source of it originally. But what we're looking for is what was the pre-development of the site? So what was it originally before man came and decided to build something there? So was it a wetland? Was it a farmland? Was it a woodland? What are some of the previous structures that may exist? Is there an old sinkhole at the site that may have gotten filled in, an old lake or an old wetland that may have gotten filled in? Or as we'll see in the Regency Park, or the Regency example, like it was an old strip mine or an old exposed sand dune that is then now a roadway or neighborhood. So what we'll always look for, and this is an example of these historic aerials taken from a Geotech report that I'll post. We would always look at it in the current day location. So this one here, this is the current day just from Google Earth or something. And then we'll also look at them from various years. So 1982, 1980, or 1995 here. So obviously here you can see that 1982 historic aerial has no highway development. And you can also see that there seems to be this dark depressional area here that could be a low body lying of water, or a wetland, or an existing sinkhole that now we don't see in today's map. And you don't see that when they built the highway. We also see that nowadays, in the current map, we have this big pond or water feature here, and we didn't have that in the existing one too. So those are things that would need to be looked out for, based off of, if you were to develop this site, what could the anticipated soil conditions here? Here, if we see this water feature right here, maybe we should focus more subsurface testing in this location to make sure that it was properly filled and not just capped, essentially. So it might have future settlements. So this is through the historic aerials, and I'll show you the map function there and the links associated with that as well. Okay, so once we have all of those, every site, normally you would want to look and actually perform your own standard penetration test or cone penetration test. But a good starting area to see and anticipate what the nearby subsurface conditions might be is to look at the soil or the DOT boring location. And what this really helps us do is look for any potential issues. Like if we know we have a lot of organics nearby from the other standard penetration tests, then we might be able to then we might want to focus on certain areas that might have organics on our site too. Other examples might be depth of limestone. So when you are actually contracting out drill work, it's all going to be accounting to the depth of boring. That's how much you charge. And it's also depending on how much it charges is the price of, or so how much casing that needs to run. So that's again a function of depth or groundwater table. So if we can use the nearby data, nearby standard penetration tests, even if it's not actually at our project or underneath our project location. In some areas of Florida, the horizontal or spatial variability really doesn't change too much. So we might have a little bit more confidence that if we have a standard penetration test performed, 200 yards or a few hundred meters away, then maybe that standard penetration test will actually reflect what we have underneath our site. So this is a really good gauge to get an understanding for prices, for potential issues, as well as anticipated soil conditions, so you can better refine your specific subsurface investigation techniques. Okay, so the last one is the Web Soil Survey, and this is through the United States Department of Agriculture, so USDA. It's a massive database. It's for the entire United States, and it covers about 95% of the landmass in the United States. Now, important thing to remember with this disclaimer here is that this was intended and still is intended for agricultural use. So we're only able to get an understanding of the first 80 inches of depth, so very shallow. So if you're only doing a roadway project or only doing a shallow foundation, then this might be a good resource. But if there's any deeper excavation, anything that goes over a few feet in depth, then this isn't going to tell the whole story. And we're going to have to rely on some of the other subsurface investigation techniques. So what this allows us to do, this tells us the soil types, and there's some really weird and funky names for these soil types, but essentially why we classify these based off of these soil types will tell us then a little bit about the behavior. And so these classifications are on the county level, which makes it kind of confusing. For whatever reason, each county decides to classify their own. But then later on, now more engineers have provided input, and you can find classifications from actually AASHTO or USCS on here as well. But what this allows us to do is get a good spatial variability where everything else has been just a point data set, like in the FDOT boring viewer. It's just one single point. This gives us a little bit better insight on how the surface changes, in the entire project area. So we're actually able to get some good information, some good data from this. We can get soil properties like percentage sand or percentage clay. We can also get a rough estimation of the permeability or the erosion susceptibility, or even the classification, so we can get some actual physical values there as well. Now, this is not intended for design, but it's again intended for us to then better shape or better refine our subsurface investigation. So some of the issues that we might be able to encounter through the web soil survey would be the presence of organics. So if there's a bunch of organics at the ground surface, and we need to get our truck rig in there to perform a boring, then we might need to choose a different option. Instead of just this heavy truck that would sink in the mud, we might need to bring an amphibious rig or a lighter weight ATV rig. This also helps us identify some of the other like clays at the surface, So this is a good first look into the area before we get boots in the ground, before we actually bring trucks out there and perform these tests. So here's some examples too of just some of the mapping techniques, and I'll go over this too here. Part of your lab, your final lab, is going to be choosing a location, any area of interest, any project. It could be developed, it could be undeveloped, it could be your home, it could be your church, it could be your favorite restaurant, somewhere in Florida. Doesn't have to be in Jacksonville. And you're going to write a geotechnical engineering report for that location. So since I went to UCF and spent 10 years here, this is just an example showing this. Let's just say, spent a long time here in the athletic village there at the north side of campus. So let's say this is my area of interest here. So this is the current day, 2021 Orland map. And what we'll first need to do is learn how to use Google Earth or any other type of mapping, but I highly suggest Google Earth in order to produce a high quality map like this. So you're going to have labels, you're going to have outlines, you're going to have significant features here like the roadways. So if any person picks up this report, they can actually determine where the project is with respect to the general like geographic landscapes there. So this is the current day satellite image. If we look at the historic aerial, this is from April 10th, 1940. So this is what most of Florida looked like back then. You see the approximate location, McCulloch Road. I added all of these colors in here. If we go back though, you can see these lakes are relatively the same. And these are the distinguishing features that allows us to determine where we are here. But what you can also see is the Alafaya Trail, even though it was very, very small, it was probably still a trail back then. But you can see that running north-south there. And we see that here too, which is now State Road 434. So obviously the university wasn't there at all. Let's see if you can pick up Lake Pickett. No, I didn't do that. But what we do see from this is we see what seems to be a creek bed running through here. Let's see if we can still pick that up. It looks like it's a little bit harder to define there, maybe with this change of colors here. But we see obviously there's a lot more lakes now. And this is just due to the construction of the project location. But some of the other things that we could point out too are some of these little closed, smaller lakes around here. Now, these could be historic sinkholes. These could be just like karst activity. But what we do see is when we look at the old map is, okay, maybe we have a little bit up here and maybe this one right here, but there could be some that we actually covered up. Actually, interesting enough, like this was one of the issues with UCF when they were building the HPA building right here. They found an old sinkhole an old water feature that essentially just had about like 4 feet of fill on top of it. And that was just when it was a farmland. They needed to build a road over it, so they weren't thinking a massive campus was going to be here one day. So farmer just took an excavator or shovels or whatever and just filled in the sinkhole. That gets lost to time. It's not documented. It's not on the historical records. And then whenever they come and try to build a structure there, then they have settlement issues, or they have loading issues or compressibility issues. So this will give us a little bit insight here. You can see these little closed dots there that might tell us some warning signs or some areas to like look into more consideration before, as we develop or as we increase the area. So if we move along here to, this is a 1972 aerial, and I cropped it up a little bit here, but you can still see the same lake. You can see the athletic village is just now starting to be formed. McCulloch Road is starting to get formed a little bit up here, as well as some of the entry roads there. You can see Lake Lee down here, and that's, well, it's not there, but you can see this lake down here as well. And so let's try to look in a little bit more detail. So this little pond right here, it looks like that's this pond right here. And if we look back at the other one, that's this cypress pond right here too. So this one's left pretty untouched, and that's probably why the road bends that way around it. But some of the other ones, may have been covered up. Like right here, this might be the one in front of the student union, or that the student union is built on. And then this, this Lake Claire up here, this is still exactly the same too. So if we're looking at developing this area in itself, it looks like it was relatively dry. Maybe this might be a seasonal wet spot, but there's nothing too concerning from historic aerials when we compare those two locations. So if we look at the FDOT boring viewer, this is what we would actually look like here. And you can see we have a couple borings in this location. And this is something that you're going to need to provide as well, like the proximity of this. Now, in this case, since we're in an urban area, then there's a lot of good, there's 0.6 miles away from our area, 0.9 miles, 0.9 miles. So we can get a good understanding, hopefully, of what soil conditions might be here. Ideally, what we would like is another data point up here in the northeast, so we can interpolate between those two. But again, for this project, we're just dealing with what we have. And at the end of the day, you're always still going to be performing standard penetration tests or cone penetration tests in this location. So let's look at an actual example of this. First, let's do a Jacksonville one. So for Google Earth, everyone is allowed to have Google Earth for free. So I highly recommend downloading it. All this stuff on the left-hand side, don't worry about all that. This is just my own stuff that I have for research and everything. But if you open Google Earth, you can just like Google Maps, you'd be able to scroll around. Let's do that example there of what used to be the best mall here in Northeast Florida, the Regency Square Mall. That's now like half abandoned and stuff, much like the rest of Arlington. But let's get some insight on how this is developed. So right here, you can see on the left-hand side, you can toggle all the roads on and off. You can actually toggle the terrain as well as the 3D buildings. And some of these are actually kind of cool with the 3D buildings. Doesn't look like they have any for downtown Arlington. I wonder why, but you can actually see some of the 3 dimensions on that, which are pretty neat. So I'm just going to go ahead and turn off all the places because I don't care about all the Chipotles and all these in this area. But what we can do, one of the interesting things here with Google Maps, is you can actually go back and see all of the historical imagery, not to the extent of the historical aerials that UF has, but we can still get a good insight. So right here, if you click this, currently we're viewing 2024, and you can start clicking the backwards, and you see some of them aren't very good. But what we can see is how the area has changed over time. So you can see the furthest one that we can go back to is 1985. And since this is satellite, it's not very clear. It looks like they're developing some of the stuff. I can turn off the roadway here. It looks like, yeah, this is still kind of the old strip mine over there. But it can be kind of interesting sometimes. Sometimes you can get a clear one like this here. So this is 1994. Look at that, the mall's popping. All of your parents are probably here, at the Dairy Queen or whatever the heck they did in 94. Never mind, whatever they did like in Stranger Things and stuff. But you can see up in this whole north area. Let me see, was actually the road built? Yeah, so the expressway was built. Oh, actually interesting. Let's look and see if this was the old Dames Point Bridge before it got hit. They might not show it. There's the Dames Point. The Dames Point. Okay, so this was both 1985. They didn't build the Dames Point, and then they have it blocked out for some reason. That's weird. Well, Dames Point used to look a lot different. It actually got hit by a tanker, I think. Maybe that's Tampa. Maybe I'm misremembering everything. Anyways, so let's see again. Yeah, so you can see how it changes a bit and what it looks like, the heyday of it with actually people there. But in this north area, you can still see what looks like an undeveloped area and a lot of like lighter material, which might be a sand, but this allows us to see how it was developed around. You can actually see people at Kona Skate Park still back in the heyday there too. But anyway, so this is a really valuable tool. What I want you guys to do for your lab report would be just to produce a current day image of this. So what we can also do, let's say you want to add a point of interest. So let's just say Regency Mall, RIP. I should have done the landings or something. So yeah, we can move this around a little point like this. Then we can move this by clicking on it wherever we want. So this is going to be that location. And let's say we want to produce a map out of this. What we do up here at the top, as long as my zoom thing doesn't keep popping up, but we can go here, save image. And so if we click on this, then what it does is it produces a map, and it's really nice. It actually scales. It has a legend here. You can move and you can click on any of these things and move them around. And so if you have a lot of data points, it'll automatically populate this legend. You can change the map by clicking on it. So like whatever, if it'll actually let me type it, it won't let me type, but you can change that there. What you can do is change the resolution. So right now, usually I want to change it into a little bit higher resolution, and then you can change the scaling as well to bump those up here. So this is what you're going to need to do. I want you to highlight the region. You can add a polygon if you don't want to use a point, so you can like actually highlight the whole thing like this. If your project is an actual structure like that, and so you can then change the color and just outlined and not filled, whatever, something like that. So whenever you have this, then what you would do is click save image, and then it'll save it, in wherever you want. You can choose a JPEG or a PNG file, and just save that. So that's what you would incorporate into that. Okay, so that is our Google Earth. Let's look at some of the other things here. So let's look at the same region for the USGS map download. So if I were to just click on that link that I gave you for the USGS, it would bring you to this. We see a similar thing to the Google Earth, where we have this like little GIS or this map of the United States GIS. You'll see on the left-hand side you have a map extent, polygon, points, and this is where we'll put in the location that we care about. But the easiest way to do that is to actually find that location on the map by scrolling to that same location. There we go, Regency. And so what I'll do is let's just do the extent of that area and see what there is. So I'll just do, oops. So you just click, sorry, let me redo that. Click here. So there, you can see the Regency Square Mall there. So I'll click there. Once we have this, what I'll do is I'll click search products. Then boom, what we see here, we see there is the current topos right here, as well as the historic topographic maps. So for the current topo, right there, we have 7.5 minute map of Arlington, which is perfect. That's the one I would need. So I can actually click download, or I can view it, but I want you to download it as a PDF, so you'll download it. And then we can actually pull that up when it's done downloading. Let me just pull it up. So it's actually a file. Okay, so this is what it would look like. So you can see it, this is the entire topo for Arlington. We can't zoom in any more than this, but it's a nice, like, official map from the USGS. There's a lot of information on this PDF, so it takes a while to load, where it goes all over the place. But you can see it has scaling here in the bottom right. It would let me zoom in with all these layers and stuff of CAD on top of it. We can see this is the Regency area here, Regency Square Boulevard. We can see the Woodland Acre or Oakwood Villa, or like Sin City if you live over there at all. I'm familiar with that, off Strawberry Creek. And then Southside Boulevard here. And what we can see is the topography here. This one specifically shows the contour lines every 5 feet. So we have the 50-yard or the 50-foot elevation map here, and then each one is going to be descending in that. But we're able to identify some of the locations here where we see like wetlands, some of the other creeks, and some of the existing structures. Like, so these data points actually mean something, and you can look down in the table, sorry, at the very bottom, and it'll tell you the legend of each one as well. So this is the 2021. This is following the 1983 North American vertical datum. And you can also see where they get some of the other information from there as well. So this is, again, like a bigger picture thing there, and this is the newer one. But what we can also do is look at the older one as well and compare it. So let's look and go back to our website here. And what we can see here is we can look at the historic topographic maps. So you can see we have one from 1950, we have one from 1963, we have one from 1994. So a bunch of different ones there with varying scales. Actually, it's all the same scale. So this 7.5 minutes, 7.5 times 7.5. They have different shadings in them. Those are just the different sources, but you can see this one was published on the 1st of January, 1950. So let's look at this one. Let's download this one here. This one's from 1950. And I have it. That is this one right here. You can see the map looks a lot different, a lot less developed there. We can zoom in. You can see right here, the Oakwood Villa neighborhood still here. So if we compare that to, the 2021, we can see that one's still there, but the whole neighborhood to the south of it here in Grove Park and Glen Lea area between Beach and Atlantic, this one was not developed yet. You can see here the whole Southside Road, or the whole Southside interchange, is not connected. And we see the strip mine here in this Mount Zion Church as well, where we used to have where now we have the Regency. So by comparing those two and comparing historic aerials, you can get a sense of where some things might used to be. Like a good one, for example, too, here, let's see, Southside. So you can see Southside, you can see all of these. Well, this is the Flagler Lookout Tower, which is kind of funny. Like off Southside, right by the dinosaur, you can probably still see that lookout tower today. So that's been around for a while. You can see the rest of Beach Boulevard is under construction. This is actually UNF right here. UNF was just a sparkle in the Skinner's eyes. It was not even thought of yet. But you can see some of the old churches and some of the other like water features that are now covered up where there's residential areas. Now you can also get some pre-existing information, like obviously this is a strip mine, and now if we look at the topograph here, this is where the highway was built. So that was probably good information for them to know before they built the highway there. Well, you can see other things too. Let's look at 1963. I think this was the one that actually had it in this area. So this is 1963. The 2021 is bugging up all my RAM. Let me just okay. So we see a little bit more urban development up here. You can see actually this is 1963, so the outline of the Regency Mall is already built. I don't know why it won't let me zoom. Yeah, so we can see the outline here. Still the strip mine shown up here. And now we can actually see the, these neighborhoods starting to develop around it. And then some of these water tanks still existing. Now there's a good one. Yeah, this is a great example right here. So for whatever reason, this is something you don't want to see if you buy property and don't check the historic aerials. So if or not historic aerials, so things were just different back in the 60s. 60s in Jacksonville was weird. JEA used to just dispose, like have these wetlands that they would just dispose excess sewer into. And they were like, all right, well, nobody's ever going to develop in here. And then, oops, okay, now there's a highway moving right here. And if you're familiar with this area off of Mill Creek, there's a bunch of apartments popping up. If you look at the 2021 right there, that's why we have these little blue dots. They don't really tell you what that is, but these are old JEA disposal sites that were essentially lost to time. So landowners might buy this not knowing what's actually this site was used for. And then when they go to develop it, a buyer or they try to sell it and a buyer will do their due diligence and notice like, hey, like you're going to need to test the groundwater, you're going to need to test the soil. And, it might end up costing somebody, a lot of money in that case, just because they didn't notice this here. So some of these things, again, this is for the whole site investigation. You can see, unfortunately too, this, if you're familiar with this neighborhood, it's not the high, it's a lower income neighborhood. And, unfortunately the city treated it that way, with sewage disposal sites and just low lying, poorly developed areas. So, that's just kind of how it was. And, that you can look at some of these historic maps to get a better insight of how it was developed so you can better plan for site development nowadays. Okay, so all of that stuff, fun stuff here. Let's look at the historic aerials. So click on the map there. You see a very similar thing. The whole like interface is exactly the same. Or sorry, so click on the link. You're going to zoom in. Let's look at that same area just to keep consistent. Let's see what we can find here. So we'll zoom in here into the location that we care about, the Regency area. And then let's select an area here. So let's just look at this whole interchange again. So as soon as we click that area, we'll click search, and then it should populate all of the historic aerial flight patterns that we have. So we see 1960, 1970, 1952. So since we know it seems to be developed around 1960, let's be a little strategic here. Let's look at this flight here, 1960. So we'll click on this one. And then what it will automatically do is bring you to all of the first picture in the whole slide deck. But what you're going to want to do here now is actually go to the search results, and you can actually see which one will overlie the specific area that you care about. So right now, you can see the outlined green one. This one is, each one of these is a historic aerial map. So this one is like a spy plane shot or whatever, not a spy plane, but like one of those imaging planes. So what we will care about this one because that's the one that has all of the area in it. So let's look at that. And this is what it looked like from the sky, from bird's eye view of in 1960 in that area. So some of the things, unfortunately, it's not marked out very well, or you're just going to have to compare it to maps to actually get a comparison of it. But what we can see is that this is that interchange there, but this is South Side, and then this is that Atlantic Boulevard and that interchange here. So our little sewage disposal site is actually up here, and you can see the tanks there that are now lost to time, right on the side of this strip mine, and that is where the mall was built right there. So this would be a helpful one to actually see, what was developed around. You can see some of the existing houses and lakes, and what looks like this was an entire strip mine here too, as well, off to the west side of it. So you can see the outlines there of Craig Airport too. So let's go back to the all the volumes to see what else we can find. So let's go a little bit sooner. Let's go to 1970. So let's just go back to the search here to see all of them. Okay, so 1970. So is there something? Yeah, 1970. So let's see. This should be developed by then. We should see the oops, search results. Okay, so let's click on this one. You can see some might not fully overdevelop everything. All right, so this is starting to look more familiar. So actually half of Regency was built first, it seemed like. Regency Mall now covers over here. We can see the whatever first shopping plaza pop up there. And then the Arlington Expressway now that goes over the Matthews Bridge there. And the whole thing here still is the strip mine. So we can able to identify that, but now we have Monument Road being constructed that goes out over to like Beacon Hills area and everything. But we can also zoom in and take a look and see, okay, so that sewage disposal site still seems to be there. So it was most likely still active in the 70s. So you can actually do some reconnaissance and look and see at what time that we don't see this despite this site anymore. And maybe that's when the last time it was active, Same down here, you can see the Oakwood Villa area, the Woodland Acres area starting to get developed. And then, yeah, this is now if you drive on Southside, these are all houses with those big sand dunes, those big white like dunes and everything. And you can see that was once a mine as well, a strip mine as well, that was used for sand, either for concrete or for fill material. So now we've developed that. So the historical aerials are, you could spend all day if you're interested looking through some of these and to see how the landscape changed. Downtown area of Jacksonville is always really interesting to look into, especially some of the older ones too, like 1943. Like for example, this stuff you don't have as many of them, but you can really see what Jacksonville looked like pre everything, and this is when it gets really hard to discern. This is Pottsburg Creek. And then, this is Oakwood Villa here. So this is Woodland Acres, and there's just nothing. There's not even any houses constructed yet. They just have the roads built in. And this is when this creek here was actually dammed which caused a lot of flooding in this area. So yeah, you can put your little forensics hat on. You can spend all day on this stuff. But let's continue to the second to last one, which is the soil boring viewer. I don't remember the order I have it in. Let's do the web soil survey. Okay, so if you go through the web soil survey, let me just go back to the original website here, just in case I can't remember what link. This is our USDA web soil survey. So you'll scroll down and you'll click the Start the Web Soil Survey. And there's a lot of data on here too. So again, be patient with it as the map loads. We see the entire state of Florida here, or the entire US. With this one, you have to kind of do this dumb, choose your area to zoom in. So you can't just use your little mouse scroller. So it might take you a little while to refine it, but let's look at the same area here. So, okay, so let's zoom in a little bit more. All right, so that's the south side area. So once we have this area of interest, or once we have the map loaded close to the area, what we're going to do is click this button right here. This is the AOI, or area of interest, as a rectangle. So what we'll do, same as before, you click and then you drag, and then this is the area there with our Regency Square Mall. Let's look at the area of interest here. So now we're going to create that area of interest, and then once we have this hatched region here, this is when we can actually start looking at the soil maps. So you're going to click on this tab right here that says Soil Map. And then boom. So what we actually have here is the distribution. It shows you the distribution of all these different types of material, sands or whatever we have at the surface. And if you zoom in, which you can, where you can pan around and see, each one has a number associated with it. So if you look here, let's just zoom in a little bit with you can see this says 87, 99, 32, and we can actually go and see what those represent. So 99 is water, which makes sense. 87, this is Devonian muck or Devonian muck. And what we can actually see is from our area of interest, we can determine how much or what percentage of our area interest is actually that material. So usually what this is used for is to identify some of the mucks, like depressional soils, or like right here. Well, this is all good stuff, but like here, mucky fine sand. So we might want to identify where that is. A lot of urban land because this is already developed, but you can see like some of these muck locations. And so if we were to do testing in this area, then we would most likely need to bring a certain type of drill rig that could accompany this type of thing or this type of soil. Now, what you're going to see in your lab report requirement is you're going to need to also include some type of soil property. So what you can actually do is up on this tab right up here, Soil Data Explorer. Let's look and see what type of data is available at this location. So we're loading our map up again. I'm just going to focus on this neighborhood because it has to be undeveloped locations recently. So we can see let's go back to intro to soils. Okay, so we have all of these different categories. Let's not worry about that. So we can see there's construction materials, suitability, the soil properties and qualities. This is going to be some of the things that we've seen before. So soil qualities and features, if we click this tab down, then boom, look, these words look familiar. We have AASHTO group classification, group index, the subsidence or unified soil classification system, as well as the depth to bedrock or depth to any soil layer there. If we look at the physical properties, then look at this. We see, we can actually determine and estimate organic matter. We can look at bulk density. And again, this is only for the ground surface material, but still is really helpful. We can look at plasticity index, percent silt, percent sand. So let's just look at the percent sand, for example. If you click on this, it's going to have all of this stuff right here. What for geotechs, what we would always do is click this all layers weighted average, and then you'd click view rating, and it's going to load. What it does is produce these nice little maps here of all of the material, and then it tells you the rating, so the percentage of sand essentially. So we can see most of these are going to be pretty high percentage sands, and that's why there was mines in this area. You know, it's really, really good. Like all of these are going to be high percentage sands, 94, 95-ish percent sands. But some of these, Devonian muck, this is going to be 0%. This pits, where's a pits? That must be like an old like borrow pit or something. I don't see where that is on the map. 55. Yeah, I don't know. Some of these are going to be hard to identify because again, this is like supposed to be for virgin or green space land. But we're able to get some identifications there, some insight for that. Let's look at another property just for example. Let's do the actual like soil qualities and features. Let's look at USCS. So same as before, we'd have to go down, click. I guess we don't have to edit that at all. So we can just click the view rating. And boom, look at that. We have SPSM, which is a silty fine sand, and then we have some areas that are PEATs, PT, as well as SPSM. So this is kind of a boring spot, but throughout Jacksonville, you might see clays or you might see silts actually on the surface, and they color coordinate it here, which is really nice. Now, what you may notice, like all of this urban land here, since the USDA was developed after like the 60s and the 70s and the 80s, I think it was like in the early 90s, where there is urban developed land, they don't account for. So if you're doing this in downtown Jacksonville or someplace where there's been a lot of development for a while, you're not really going to get a lot of information from that. But a lot of these areas where you would be further developing, you can get some insight on that. So this highlights 22 and 87 in the red color, and we can see 22, that's the peat, as well as 87, those are both peaty soils. So those might be the regions that we have to look out for. Some of the other things, let's see, erosion properties, water features. So depth of water table, this is a really helpful one as well. View the rating for depth of water table. It's all in centimeters because it's kind of stupid, but you can see at least which ones are going to be greater than 200 centimeters, which really doesn't tell us that much, but you can get an understanding of which one is at the groundwater surface, or at the groundwater table is at the surface. So these depressional sands, again, 0, 0, 0, 0. So those ones might be the problematic soils, those red ones they're shown in the map. So you can do a printable version here. You can screen grab this, or you could actually create a soil report too, that you would then upload in your database or in your report. All right, last one here, soil FDOT public soil boring viewer. So this one is only for Florida, and you'll see the data is still being populated slowly. It started in District 5, which is Orlando, which is why they have a lot of data down here. But now we're starting to get a little bit more up in Jacksonville. So we would zoom in. Again, let's focus on that Regency area for whatever reason. Let's see what's there. Okay, so there's not much, but we do have one boring here, B1. If we click on this, we get a little bit more information on it. We see it's a standard penetration test. This is the actual FDOT financial number here. So we can actually look up more on the project if we want. We can see the latitude, longitude, and as well as the station. And then here, so this PDF, if we scroll all the way down, this is actually going to be the geotechnical engineering report that shows that boring. So here we go. This is our boring right there, our standard penetration test, our B1. And you can see it was only to a depth of 15 and a half, oh no, elevation of 15 feet. So how deep is that there? So if the ground surface elevation, so 55, so it looks like a, what, 60 foot, 70 foot boring. And you can see the blow counts accordingly there too. So this is kind of nice. We see also some lab testing there too nearby, and it's all going to be sand, which makes sense. That's what we've been seeing and so far in everything, right? We've been seeing these sands. Let's see another one. I'm assuming this is all going to still be sands, but let's look at B3. Let's see if anything is fun here for this. Okay, this is for a pond. So this is in AASHTO. So there's a bunch of borings. They're all going to be shallow. And this is AASHTO classification. So we're just going to say, forget that. Let's see what else there is. MA, this is usually mast arm. So this is for like a traffic signal. Let's see if this is a, okay, so same stuff here. All right, all sand. So this is boring stuff. But you get the idea here of the tool here that we can use. Obviously, this is for FDOT, so it's going to be focused around roadways. You know, if you look at downtown, some of the newer bridges down there, then you can actually see a lot of the data. So the Fuller Warren Bridge, let's see what it looked like here in the middle of everything. It's B17, so no, you can get, these might be a little bit older, but still you can get a good insight of what it actually looked like. So you can see these were performed over water. So the water table is there, obviously open water. A lot of times, actually, that's kind of funny. 4 feet of concrete is what they drilled through, because back in the day, they used to just dump stuff in the St. Johns River. So you drill through that. You can see a lot of silt, a lot of silt, and then you hit this like clay layer down there. And a lot of lab testing, because this is for a bridge. And you can also see they did PMT, which are pressure meter tests too. So they actually have a lot of data here for this. So this gives us the stratigraphy downtown, you know, if you're ever interested in wanting to look through some of those there. Okay, I covered a lot. What I do want to look, or what I do want to review is this lab experiment number 9. So this is an individual assignment. It's not going to be due until the end of the semester, but I do want to show it, or at least give you the opportunity to work on it like here early on, because it is going to require a little bit more individual effort than the other typical group lab in the experiment, or in the group experiments in the lab. So the whole goal of this is you're going to prepare a typical geotechnical subsurface report. You're just going to choose any location around Florida. It doesn't need to be in Jacksonville. It can be anywhere in Florida. It does help if it's near developed areas, because then you'll have subsurface investigation techniques. But your report must include the following. So you think of these as like a little check mark. So you're going to include a cover page, paragraph overviewing location. So why did you choose this site? A map of the project area. So that's going to be through Google Earth. Your topographic map, which is the 7.5-minute one using the USGS. Historical area of the pre-developed site, and as well as any discussion that might be about what you see from that. And then USDA soil survey map with relevant soil parameters. So just choose a soil parameter and why you decided to show that. And then as well as a nearby SBT result, at least one from the FDOT website. So here, this is a detail of each section here below, as well as the links. So you can read through these. And again, like, make this something that you're interested in. Like, that's the best way I can say it. Like, if you just choose a random location, then this is going to be a sucky, boring report. But if it's someplace that is you have personal relevance for, you're interested about, then this could be a really interesting report because you get a chance to learn more about it in detail. So this won't be due until the end of the semester, around finals week, but still this will be posted. Lab number 9, so it's a little bit out of order, but I wanted to at least give you the opportunity, especially when you're traveling home for spring break, to look into it a little bit more detailed. So very similar to that last lab report from our CE materials class that was individually based. Kind of same premise here, except this will be the geotech side of all of this. So thank you for sticking around. I know this was a long lecture, a lot of material here. I will post these slides, so please go ahead and review those if you need to, as well as the links and as well as the page, and send me any questions, any emails. If you want me to review the location that you've chosen, then I'd be happy to do that, or help you find any more data, then I'd be happy to do that too. So thank you guys, and hope you have a great week. Happy spring break. I'll see you guys in a few weeks for our exam review.